Hello, grade 10s. Welcome to Area of Shapes lesson. Basically, talking areas of shapes. Last day we talked perimeters. Perimeters is distance around, as if you were walking around a shape. If you wanted to put baseboards around a room, a fence goes around a yard. That's perimeter. Today we're going to review area. An area basically covers things. Wallpaper covers the area of a wall. A rug will cover the area or part of the area of a floor. That's what area talks about, everything covering. We use squared units, centimeters squared, kilometers squared, when we're talking area, because when we talk area and covering, doesn't matter what the shape is, that if I have this particular blob, there's a length and a width that this is covering. There's two dimensions that it's dealing with. So we have squared units to identify its two dimensions area. Now, there are certain things for reference, like we talked about the imperial system, the metric system. If you want to estimate the area of something, there are certain examples. The tip of your thumb is about a 1 by 1 centimeter or 1 centimeter squared. The palm of your hand is about 4 inches by 4 inches, so 16 inches squared. These are just reference if you had to estimate something. But what we're more focused on is actual calculations. That's what we need to understand and review these areas, because these are going to be used when we get to three-dimensional shapes. So here we go. Areas are based on formula. Formula are given to you. You have a formula sheet available to you in Brightspace, and it shows you in lists, and I showed it in a previous video. You can look to see what formulas are given. But you have to understand what each formula means, not just, oh, it's these two variables, but you have to know. So we're going to go through those fairly quickly. Most of them are review, maybe a couple new ones, but we'll talk as we go. Area of a rectangle, there's two ways you will see it. Length times width, or at times you will see it as BH base times height. I tend to focus on length times width. There's no right or wrong. But if I wanted to calculate the area of a rectangle with a length of 6 and a width of 5 centimeters, area would simply be length times width, or 6 for the length times 5 for the width, which is 30 centimeters squared. Don't forget it's squared units. Area of a square. Well, square is kind of special because a square has 4 equal sides. You will see that some students will put, oh, that's a length and a width. Area of a square is length times width. Well, that works, but it's not the best formula, and you're going to see later on in this lesson why it's important to use the better formula, that since length and width are the same in a square, they're often referred to as just, this is the side length. It's the same everywhere. So it's side times side, where the area of a square is side squared. You multiply it times itself. So for the example, calculate the area of a square with 4 centimeter sides. Area is side squared. So 4 is our side length, and we want to square that. 4 times 4 is 16 centimeters squared. That's one of those little formulas that can become useful in questions that become a little more complicated instead of just LW for a square. Now, the area of a triangle is kind of unique for several different reasons. There's a couple different ways to write the formula. A lot of people use the area of a formula as base times height divided by 2. There's nothing wrong with that formula. I personally don't like fractions, so I like, instead of showing divide by 2 as a fraction, you can also get half of something by multiplying by a half or the decimal equivalent 5/10. For me, the area of a triangle is 5/10 base times height. That's the formula that I like to use. Nothing wrong with base times height divided by 2, but you will see me use that because dividing by 2 is the same as multiplying by a half, which is the same as multiplying by the decimal form of it. So that's why I like 5/10 times the base times the height. Now the other thing that's important is a base height combination. Base doesn't have to be the bottom of a triangle, but usually that's how you'll see it drawn. The height is the distance from the base to the opposite vertex. So in this case, if B is the base, from the opposite vertex to the base, that's the height there. In a right triangle, it's kind of special because there's your base. From the opposite vertex to the base, there's your height there. The base and height, not only is it the distance from the base to the opposite vertex, but they have to meet perpendicularly. So again, here's your base, opposite vertex, distance meeting vertically, or meeting perpendicularly, that's the height. The reason you have to be careful is you might have a sketch that looks like this, and you have that. The base doesn't always have to be the bottom of the triangle. The base is one of the sides. There's your base, and from the opposite vertex to meet the base at 90 degrees, there's your height there. So it's just understand that base is one of the sides, and the height is from your base to the opposite vertex, meeting at 90 degrees. So, a couple things to think about with triangles, but we want the area of a triangle with a base of 10 centimeters and a height of 14. So area is 5/10 base times height. That's what I like to use. 5/10 times the base, which is 10, times the height, which is 14. That works out to be 70 centimeters squared. Shapes that you have seen and worked with in the past. Parallelogram. Parallelogram's a little like a triangle or a rectangle, but not quite the same. A parallelogram has a base, which again is one of the sides. And the height is the distance from what you identify as your base to the opposite base or opposite side. So if I'm going to use this as my base, the distance from my base to the opposite side, that's my height. And all you need for area of a parallelogram, like the rectangle, is base times height. I think this is one of the reasons I like LW for a rectangle, because I like base times height for a parallelogram. You have to be careful that if we take a look at the example, and I'll put it onto my sketch here, it says a base of 12. So that could be 12 and a height of 8. A lot of students will put this angled side as 8. That's not true. The height of 8 is the distance from base to base. So this would be 8. And I don't know exactly what that slanted length is, but it's going to be a little bit longer because it's angled compared to the height. So this would be like a 9 length. So you have to make sure you're labeling your parallelogram correctly. Base, one of the sides, height, distance from your base to the other side. So in this case, calculate the area using base times height. Base is 12, height is 8, 12 times 8, 96 centimeters squared. Formula is given. As long as you have the formula and understand the formula, you substitute in and solve. Now you have a trapezoid. Trapezoid is a shape that you've seen before, but maybe not worked with a lot. Area of a trapezoid. Again, choices. Trapezoid is the height times the sum of the bases divided by 2. So there's what the formula for the area of a trapezoid is. Again, a little twist. I don't like to divide by 2. I prefer, because dividing by 2 gets half of it, I'm going to get half of it by multiplying by 0.5. So we have 0.5 times h times the sum, adding the bases together. Two formulas that really represent the same thing. Now with a trapezoid though, you have to be careful. You have base 1 and base 2. It doesn't matter technically which is B1 and B2, but your bases are always the parallel sides. So we have to make sure that when we have a trapezoid, a four-sided object with one set of parallel sides, those parallel sides are labeled as B1 and B2. They're parallel, but they're not the same. And the height in our formula is the distance between those, and I can even add the word parallel bases. So the distance from the parallel sides, that's the height of the trapezoid. So a shape you've seen, but you're going to probably be working with it a bit. So we want the area of a trapezoid, a base of 10 and a base of 16, and a height of 14. Well, if I wanted to sketch this, I could sketch what a trapezoid sort of looks like. What could I put in? I have a base of 10 and a base of 16. So 16 and 10 would have to be the parallel sides. And then I have a height, distance from base to base of 14. That's what my sketch would look like. Understand what your variables represent. So area is 5/10 times the height times the sum of the two bases. So we have 0.5 times the height, which we've identified as 14, but then we have to multiply that by the sum, meaning I need to add my two parallel sides. And order of operations tells me to do that first. So it's reason it's in brackets is you need to do the B1 plus B2 first. 5/10 times 14 times 26. And when you're finished with that, the area of our trapezoid will work out to be 182 centimeters squared. So shapes you've seen with the formulas you have seen, and some shapes you probably haven't worked with. The last one, we don't have to have a special name or anything because area of a circle is still area of a circle. Circumference needed a special name. But area is saying that this circle still covers a certain amount of space. And how do we calculate the area of a circle? Pi times r squared. Please don't forget that r squared is r times r, not r times 2. So we want the area of a circle, pi r squared. But the diameter is given as 10. But we have to be careful with our labeling. Because remember, the diameter is all the way across. But our formula uses the radius. The radius is half a diameter. So our radius is 5. Make sure you know what you're dealing with. Pi times 5 squared. If I do this calculation, it'll be pi times 25 because exponent first, 5 squared is 5 times 5, and then I have to multiply by pi. Using the pi button on our calculator, remember we talked about that the other day? Oh, my calculator's not up and going. Just got to wait a sec here. Here we go. Close that. Remember, pi times r squared is pi times 25. So we second function the little arrow, which gives us pi, multiply by 25, and round to whatever the question asks for. We can always round to the tenths place. 78.53. 3 tells us to leave the 5 as is. So we get 78.5 for our area. And that's 78.5 centimeters squared. Those formula you need to know. This is not new. Formulas are given. You have to be able to use them effectively. So, very quickly, pause the video. Example 1, 2, and 3, 3 shapes. Always make sure when it says show your process, I expect to see a substitution step before you put your answer. You don't have to write the formula out. You can if you like, but I expect to see numbers plugged into a formula before you solve. Pause the video, give those 3 a try, and then we'll do them together. So, first one, triangle. You have choices of formula, base times height divided by 2, or 0.5 base times height, whichever makes sense to you. So area will equal, I like the 5/10. Our base is 8, and from the opposite vertex to the base we see is 3. So we have 5/10 times 8 times 3. Do that calculation, we end up with 12 feet squared. Second one, a parallelogram. Area of a parallelogram, base times height. Base is one of the sides. Doesn't have to be the bottom. Here we see that we have a 12 side, but we do know the distance from that side to the opposite side is 7. So 12 would be a base, and the distance from the base to the other side is 7, so 7 would be our height. Area is 12 times 7, which is 84 centimeters squared. And the last one, well, we're looking at a trapezoid. Trapezoid formula. Again, I like 5/10 instead of divide by 2 times the height times base 1 plus base 2. Well, base 1 and base 2, they're our parallel sides. Doesn't matter which is which, but the distance from base to base, there's your height. So we're looking at 5/10 times the height of 3 times 9 plus 4. Make sure you do that calculation in brackets first. 5/10 times 3 times 13. And 5/10 times 3 times 13 gives us 19 5/10 millimeters squared. Please again note, show your process. Answer is not going to get you full marks. I don't trust that you've done it on your own. I want you to show me that you understand what's going on. Starting with a formula doesn't hurt. Figure out which shape you have, figure out the formula, then you can plug into it. I do expect to see, though, for sure, a substitution step before you put your answer down. I want to see the substitution step before you put your answer down. I want to see the substitution step before you work to your final answer. Show the little steps. Now we can get some situations where you have to think a bit. If we take a look at example 4, the area of a triangle is 12 inches squared. If the base of the triangle is 6 inches long, what is the height? Well, when you read that, hopefully the first thing that jumps out at you is the fact that area is given. It tells us the area is 12. Get a visual, sketch a triangle. What do we know? We know the base is 6 inches. What's the height of the triangle? It doesn't tell us. But we do know what the area is. When area is given, just like the little box tells us, substitute all values into the equation. Then use some algebra. But you still start with, because it's a triangle, start with the triangle formula. 5/10 base times height. First thing this time we could substitute in is area, because we know it. Times 5/10. We know the base is 6, but we don't know what the height is. So there's the unknown, there's our variable. So we have a little algebra to do. Start with your formula. Substitute in. Make sure you substitute in area if you know it. And now solve. Well, solving an equation. Multiply to get rid of brackets. Well, we have a whole bunch of multiplying here. So we have 12 equals 5/10 times 6 is 3. 3 times h just leaves us with 3h. Multiply what you can. Now we want to get h by itself. It's attached by multiplying. So we divide both sides by 3, and h is 4 inches. It's not 4 inches squared because that's an area calculation. We've just calculated the height to be 4 inches. So sometimes area is given and you have to calculate an unknown. Example 5, again, gives us the area, but this time of a square. So just to show you earlier in the lesson, I said area of a square, don't use length times width. Because if I said 16 is equal to length times width, we don't know the length or the width. We don't know either one of those. So I can't do anything to figure out what L and W are. That's why if it's a square, if we use area is side squared, then I put 16 in for area because that's what it is, equals side squared. Well, this time I have to get rid of an exponent too. How do you undo squaring a number? Well, it's square rooting. So the square root of 16 is 4 because the square root gets rid of the squared. So 4 is equal to S. Each side is 4 centimeters. So it's nice to start with the appropriate formula for a square. Before you get to work, let's also quickly skip over to page 37. 37 is a quick little concept that you have to be careful of. We did a whole bunch of converting, but converting square units is different. The reason being, since area uses 2 dimensions, which gives us squared units, that for every 1 unit change in metric, the decimal has to move 2 times. So this is just something that needs to be remembered from now on. Centimeters squared to millimeters squared, squared units, we have to double the decimal moves because they're squared units. So let's take a look at the example that's here. We have 8 meters squared and we want it to be centimeters squared. Well, we're going from meters to centimeters. So I find meters and meters to centimeters. Meters to centimeters is 2 times to the right. But because we're dealing with squared units, we have to double the moves. So meters to centimeters is 2 times to the right, but meters squared to centimeters squared, I have to double the moves. That's 4 times to the right. So anytime you have squared units, every conversion happens twice. Meters to decimeters, 2 times you move the decimeters to centimeters, another 2 times, 4 times to the right. So our 8, 4 times to the right, and we get 80,000 centimeters squared, because the decimal moves twice. Example 2, 350 millimeters squared is how many decimeters squared? Well, we want to go from millimeters squared to decimeters squared. Well, let's first check out what's millimeters to decimeters. Well, let's go to our conversion chart. Millimeters to decimeters. Millimeters, we want to finish at decimeters, which is going to be 1, 2 conversions to the left. So millimeters to decimeters is usually 2 times left, but because we want squared units, double your conversion moves, and it's going to be 4 times to the left. So 350 millimeters squared, 4 times to the left, there's our decimal, 1, 2, 3, 4. We end up with decimal 0.350 decimeters squared. But again, an N0 after a decimal isn't essential. Decimal 0.35 is probably a better way to write it. So squared units move the decimal twice for every 1 unit change. Same concept when we're dealing with imperial square units. But remember, imperial isn't about moving decimals, it's about calculations. So again, it's double the calculation for each 1 unit change. So if we see one thing happening, yards to foot, we have to actually do the calculation twice. So let's take a look. 9 yards is how many inches squared? Well, let's first of all think, if I want to go from a yard to an inch, just from a yard to an inch, forget about these little squares right now, but a yard to a foot is times 3, and a foot to an inch is times 12. So this calculation would be times 3 times 12. But because we want to go yards squared to inches squared, each calculation has to happen twice. So we have to go from square yards to square feet times 3 times 3. And from foot to inch is times 12. So feet squared to inches squared is times 12 times 12. Each calculation has to happen double. So 9 yards squared is actually 11,664 inches squared. There's your calculation. So lots of big calculations when we're talking squared. 2016 inches squared is how many feet squared? Well, if we're just going from inches to feet, go back to our chart, inches to feet, we see that's a divide by 12. So this would be divide by 12. But because we want to go inches squared to feet squared, we need to do the calculation twice. So 2016 divided by 12 divided by 12. And in that case, we end up with 14 feet squared. So 2016 inches squared is equivalent to 14 feet squared, because it's double the calculations because of squared units. Keep that in mind as you do your calculations. So, quick review of area, not too complicated hopefully, because you've seen a lot of it before. Ignore this, that shouldn't be there, but your assignment is going to be pages 35 and 36 in the booklet, that you're always working in, but also I want you to include page, just a second, sorry about that, page 38 from the booklet, because that's the conversion practice. And lastly, the supplemental pages booklet that you have for this unit. In the supplemental pages, take a look on page 6, questions 2 and 3. That should be done as well. So there's your assignment. Area calculations, not too difficult. Get the practice done. And have fun.